There's been nothing like OSIRIS-REx in NASA's repertoire. I like to call it the Daredevil spacecraft.
10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid Bennu and back.
Hello and welcome. I am Karen Fox with NASA's Office of Communications, and we are here today at the Dugway Proving Ground in Utah for a press briefing on NASA's OSIRIS-REx mission. Earlier today, the mission jettisoned a capsule containing samples from asteroid Bennu that parachuted down onto the Utah Test and Training Range so we can study those samples here on Earth. It's been a very big day, and we're going to kick it off with some highlights.
Entry was at
EO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating.
EO milestone. We have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. The team on the WB-57 doing a
EO
great
milestone.
job.
We have touchdown. I repeat, EO. SRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system. A sample carrying fixture.
Recovery operations. WB has located the parachute on the ground.
You just heard that confirmation from that high altitude plane locating that parachute on.
We have here a panel who will all give you some of their impressions and some information about what happened today, and then we will go on to take some questions from media in the room and on the phone line. We have with us Lori Glaze, who is the director for NASA's Planetary Science Division at NASA headquarters in Washington, D.C. We have Dante Loretta, who is the OSIRIS-REx principal investigator at the University of Arizona in Tucson. Next, we have Mike Moreau, who is the Deputy Project Manager for the mission at NASA Goddard Space Flight Center in Greenbelt, Maryland. And Tim Prizer, the Chief Engineer for Deep Space Exploration at Lockheed Martin in Littleton, Colorado. And finally, Eileen Stansberry, who is the Chief Scientist at NASA's Johnson Space Center in Houston, Texas. Lori, passing it to you.
Great, thanks, Karen. I don't even know what to say. What an incredible day this has been. It has just been phenomenal from start to finish. I wanted to start just by thanking everyone that's been here, sharing this with us here at the Dugway Proving Ground, and everyone around the world who has watched and followed along all day. It has just been amazing. We just appreciate everyone coming along with us to celebrate NASA's first ever asteroid sample return. It has been incredible. And these samples that we've brought back, and now you're going to hear what the next steps are and what we're going to do with those samples. Those are going to be a treasure for scientific analysis for years and years and years to come, to our kids and our grandkids and people that haven't even been born yet. It's going to be absolutely incredible. And another thing I just want to point out is that these types of samples, they are truly the gifts that keep on giving. They are a treasure, and this mission, OSIRIS-REx, is kicking off a decade of sample return. Following OSIRIS-REx, NASA is partnering with the Japanese Space Agency on the Mars Moon Explorer mission, which is going to bring samples back from the Mars Moon Phobos. We're going to have new Artemis samples of the moon. Feed incredible new scientific analysis and new understanding of our closest neighbor, the moon. And then capped off with the return of samples from Mars, samples that are currently being collected by the Perseverance rover on the surface of Mars. So this is just an amazing opportunity here to kick that off. I did want to make sure I take this opportunity to thank those that made this possible. What you saw today, everything that you saw, could not have happened without the amazing partnership between NASA and Department of Defense, including Hill Air Force Base, Dugway Proving Ground, and the Utah Test and Training Range. And then also I'll even add Air Force, who's brought the aircraft here that's going to carry our precious samples and some of our team members down to Houston tomorrow. It's just been amazing. And I'll also just say what you saw executed today, that precision, everything going just almost perfectly to plan, that happens because of an incredible team. Hundreds and hundreds of people. You'll hear from a few of those team members here, but I know that every person that you see is backed by hundreds of others. It's been an incredible accomplishment, and I just want to thank Dante and everyone, the entire team, for this incredible accomplishment. And then the last thing I'm just going to close out with is just a reminder that, you know, the spacecraft OSIRIS-REx dropped off her precious sample this morning, and then 20 minutes later embarked on a new journey. She's not only embarking on a new journey, but handed over to new leadership, now led scientific leadership by Daniela de la Gastina. Fantastic to see the next generation taking on this next generation mission, taking the spacecraft to explore another asteroid called Apophis. So thank you. Back to you, Karen.
Thank you so much, Lori. Next up, we have Dante Loretta, who's going to tell us a little bit about what it was like to be part of the recovery team.
Thank you, Karen. Well, today capped the end of an almost 20-year adventure for me. I got involved in this program in February of 2004 when representatives from Lockheed Martin came to Tucson and said they were thinking up an asteroid sample return mission and they wanted U of A to take the scientific leadership role. And I was brought in as the deputy principal investigator under the leadership of my mentor, Professor Mike Drake. And I just want to think about Mike a little bit here today. He passed away in 2011, just 4 short months after we won the contract from NASA to fly this program. And I know he would be super proud, and he would have loved today. He would have just really embraced and embarked on this amazing journey. When we first were talking to our friends at Lockheed, it seemed like magic. Like they said, pick an asteroid, Dante, and we'll bring samples back to the Earth for you to study in your laboratory. And I can tell you, this is the end of a very long spell. Right? We've been casting it for a long time. And it was great to be part of the recovery team. It was pulse pounding, I'm sure, for you watching it, even more for those of us in the helicopters, waiting for that main chute to come out, right? We were, with bated breath, making sure that we came down for a nice soft landing in the Utah desert. And it worked spectacularly well. I was fortunate enough to be one of the first people to lay eyes on the capsule, and boy, did we stick that landing. It was just sitting right there, you know, a few tens of feet right off a nice road, perfect place for the helicopters to land. Didn't move, it didn't roll, didn't bounce. It just made a tiny little divot in the Utah soil. So for the environmental sampling team, that was great. We had to sample the area right where the capsule landed. We picked up some background sample soils just for understanding the native environment, some dust samples, and gas samples to see if anything was coming out of the capsule. We don't think so because the safety engineers were the first ones on the scene. We actually couldn't approach it until they cleared it for human safety reasons. There was no sign of any toxic gases, which we knew was a rare event, but of course human safety always comes first, and that was the first checkout that needed to be made. There was also a very clear area. We are on a military test range. There was no sign of any issues for us to operate out there. So we got our job done really fast. You know, we did a lot of rehearsals. We always rehearse and practice on this team. That's why we always achieve these high levels of excellence. And I can't say I couldn't be more proud. And just to remind you, not only did we bring this mission in on schedule, under budget, and delivered more science than we had even thought was possible with the encounter with Bennu, but we think we've got a lot of sample in that science canister, and we can't wait to crack into it. For me, the real science is just beginning. I grew up as a laboratory chemist, studying meteorites and particles from the Stardust mission, which NASA brought back in 2006. So I really am looking forward to the next stages of this journey. People have asked about, you know, the planetary protection. We did go through extensive planetary protection reviews. We were unrestricted Earth return because Bennu is a near-Earth asteroid. Probably material from this asteroid has been delivered to the Earth at some point in the past. It's also a very small body that's constantly exposed to ionizing radiation, and no life forms that we know of would be able to survive that kind of environment. So very, very low risk. In fact, we're more worried about Earth biology contaminating the sample. The key objective for me, and one of the driving objectives of this program, is to try to understand, did carbon-rich asteroids like Bennu deliver the compounds that may have led to the origin of life on our planet, the origin of Earth as a habitable world. And so we don't want biological organisms interacting with this, so we plan to exclude it from any contact with bacteria or anything else that might compromise our scientific investigation. And the team at Johnson Space Center are experts at this. They've got a beautiful laboratory and isolation glove boxes, and we're going to start processing that sample, we hope, as early as Tuesday of next week.
Great. Thank you so much, Dante. Next up, we have Mike Moreau, who's going to tell us a little bit more about entry, descent, and landing.
Yeah, so it's so amazing to be in this moment. It's hard to describe what it means to be in this moment. I've worked on this project not as long as Dante, but a decade, through the early development of the mission to the mission operations to leading the recovery team. I was in the control center today with my partner in crime, Richard Witherspoon from Lockheed Martin, and we were directing the efforts of the team and directed all the planning that went into the activity today. And just seeing that parachute, seeing the capsule descending on the main parachute, and then seeing it just sitting perfectly on the desert floor, just hard to articulate what that means after so much put into this mission. But I want to talk a little bit about what we saw in the operations room today. It started with the amazing job that our teammates out in Denver did, the Lockheed Martin and Kinetics Aerospace and Goddard people that were there operating the mission and targeting that Earth entry interface so precisely so that we could come down. That's magic, in my opinion, and I'm a navigator, but the precision with which they do that job is just incredible. And that's what got us to the start of today. Now get to our partners at the Air Force. One of the great things about landing in this facility is the tracking cameras and radars that are around this facility. The very first signal that we had that we were on track was from our Air Force counterparts when they said we had radar lock before we even reached the atmospheric interface. So just a few moments before, but that was a great moment because the capsule was released from the spacecraft 4 hours before, coasted from a third of the distance to the moon to that point in the atmosphere, and that signal from the radar said that we were on track within a few seconds of where we needed to be. So that was a huge moment. Then we had aircraft, one of them operated by the Johnson Space Center, a WB-57 aircraft. It had infrared and optical cameras on it. Very soon after the radar detection, we started seeing signals from the WB-57, and we were able to see the actual hypersonic reentry and the fireball, and then track the capsule as it descended until the parachutes came out and landed on the ground. And you all saw that footage on the television. As far as the landing goes, we landed a little bit to the east of our nominal landing point, but that's what our amazing entry, descent, and landing engineers have been telling us is going to be happening. They've been looking at the atmospheric density and the models for the trajectory path we would take through the atmosphere, and they predicted we would be east of our nominal landing location, and that's where we landed. So I just want to say that I'm so proud to be part of this team that did this today. I'm proud to be part of the team that got us here and part of the mission operations. We had some great challenges to overcome with this mission, and great groups overcome great challenges, and it's been a pleasure to work with some of these amazing teams in my 10 years working on this mission.
Thank you so much, Mike. Our next speaker is Tim Prizer with Lockheed Martin to talk a little bit about the capsule itself.
You know, this capsule literally has a personality, and it understood the assignment. And I think back, I think your colleague Peter Smith and I got to work on Mars Phoenix, and that little lander understood the assignment too. The scientists come up with these grand questions that they're striving to get answers for. And we as engineers, for goodness sakes, it's the best job an engineer could ever have to help a scientist go gather this knowledge. It's just so thrilling and rewarding. It's so much so that we understand the question, and then we can design a special spacecraft like OSIRIS to go collect the information and the answers. And like Phoenix, like I said, I think she understood the assignment too, because Peter Smith wanted to prove that there was water ice on Mars. And bless her heart, just before she touched down, she used the thrusters to blow all the regolith off and say, look, there it is. There's your ice, Peter. Well, today, OSIRIS-REx, not only 4 hours before entry did she understand the assignment and put this SRC on a path to hit an entry interface that needed to be so precise that you didn't skip out of the atmosphere or you hit it too deep and you burned up before you had a chance to get to the ground. So she did that flawlessly with aplomb, and then she immediately turned her attention on Apophis and changed her name on the back of her jersey, and she's now Osiris Apex. By the way, we scored the first touchdown today before any of the other NFL teams did. I just want to put that on the record. But back to the SRC. She came through the atmosphere. She knew her job was to get to the ground. She also thought it would be nice and kind to land close to a road. You know, heat shield down, back shell up, basically with a little sign that said, Dante, please hug me. And it was so, she made it so easy for us. These designs are so robust that as she's coming through the atmosphere, you know, whether or not the atmosphere is more dense than it should have been or expected to be, or, you know, something in our sequence may or may not have behaved itself exactly the way we expected it to, but the subsequent things in the sequence made up for the fact that parachute came out and we touched down as soft as a dove. It was just beautiful. And you can see the excitement not only on the scientist team, but when they showed the mission support area back in Littleton and the celebration in that room, that's when it becomes real, because the thousands of hours that all of these people spent over the decade or more, right, years together, they just naturally build relationships that last a lifetime. They watch each other's children grow up over that time frame, and so their children were excited too. Family and friends were back there, and it's just a special occasion. And in this case, I mean, when we land on Mars, we don't have a lot of opportunity to go collect the parachute, put it in a bag, and analyze it, grab the avionics so we can go troubleshoot and or understand how well or they behaved. We have our hands on the heat shield and the back shell, and we can prove that our predicts and our models either were spot on or we need to adjust them. EDL reconstruction is a real thing. Every one of us, whether it's Mars or Earth, that's the first thing as an engineer that we want to do. We want to collect the data, collect the hardware if we can, which we can in this case, and understand how well our models are going to predict the next one. I can watch this video from today over and over and over. It was just a beautiful thing.
Thank you so much, Tim. Our final panelist is Eileen Stansberry, who is going to talk a little bit about what happens to the samples after they were recovered.
Thank you very much. These samples are an amazing treasure trove for generations, but we currently have a team of spacecraft engineers, scientists, and curatorial personnel working right now in a temporary clean room here at Dugway to make the sample capsule ready for transport down to the Johnson Space Center so that we can open it up and reveal this treasure. The entry into the clean room has been has gone extremely well. They're processing the capsule, removing portions of the canister so that they can get a continuous flow of nitrogen into the sample canister to ensure that there is no contamination from Earth's atmosphere into that canister and maintain the pristinity of these samples so that the science team, 200 plus people all over the world can start studying these samples. Once these samples are taken to the Johnson Space Center, we'll be able to start removing them, deintegrating the science canister, evaluating those samples, and providing them to the scientific community. I think that there's a quick video here of taking that the capsule into the clean room and being able to safe it and make sure that we retain an uncontaminated sample. As the stewards of the scientific integrity of these samples, the curatorial team at the Johnson Space Center is working hand in glove with the spacecraft engineering team and the science team to ensure that we are processing and handling this sample return capsule in a measured, methodical, well-choreographed sequence. And I'm happy to report that the sample canister was put on purge today a little bit before 1 o'clock. And so we now have a continuous flow of nitrogen within that science canister, and we are well on the way to getting that science canister ready for transport down to the Johnson Space Center. And the support that we are providing to the science and engineering teams today is documenting the handling, ensuring that we understand the environment that the science canister is in, and making way for the next generation of understanding a new world.
Thank you so much. For those in the room, do know that those videos were showing up on the broadcast. If there are any more, some of these TV screens in the back, you can turn around and try and see them. But for now, we are moving to questions. We are going to take a few in the room, and then we will also go to the phone line. If you're on the phone, you can press *1 to get in the queue. And we do have a microphone, so if I call on you, please wait for the mic. Alex Whitsey. Ours is right here.
Hi, Alex Whitsey, Nature. For Dr. Stansbury, is there anything else you can say about sort of the condition of the capsule on the exterior, what it looked like when you opened it up, anything about patterns of wear, not erosion, but just more about the physical condition as you were going through it?
When they took the back shell off, it was extremely clean on the inside. It was remarkably similar to prior to launch. Makes you wonder, did we actually open it up at some point? But I know we opened it up. I saw it in TAGSAM, and it was beautiful, clean, an extraordinary experience of seeing that the spacecraft itself must have worked extraordinarily well, that all of the engineering that went in to ensure that the science canister was going to remain clean did their job.
All right, another question in the room. This gentleman in the green shirt here, please do identify yourself. And you have a mic coming over your shoulder here.
Thanks very much. It's Ivan Semenek with the Globe and Mail in Canada. I just want to follow up on what Tim Preiser said about how maybe some things didn't go quite as expected, but then other things compensated and it all worked out. What were those things that didn't go as expected, and can you give us a sense of what some of the surprises may have been?
I can tell you what we expected to happen. If you'll remember, the peak G is about 32 Gs sensed. On the way up that pulse at a 3G level, we actually armed some triggers to start the sequence of events. We experienced the peak 32G pulse, and then we pass back through that 3G trigger on the way back down, and that initiates the sequence of events. 11 seconds later, the drogue chute is commanded to deploy, and then 360 seconds after the drogue, the main chute deploys. What I can tell you, because we all saw it, the main chute did deploy. It was difficult to see, and maybe, you know, with our EDL reconstruction and the data that we still need to go collect, we can understand some of the upper atmosphere and the hypersonic flight regime. But at the end of the day, when that main chute deployed, it basically corrected any of the sins that may have happened ahead of it, because, you know, it was beautiful, it was on time. We hung under the chute for 5.5 minutes, just like we expected. And just like I said, touched down like a feather.
Just to clarify, does that mean possibly the drogue chute did not deploy, or is it not clear yet?
You want me to take that?
Yes.
So we don't know if the drogue chute deployed, because we don't know if we can see that in the imagery. The imagery that we saw was not positive. What we do know is that the main parachute came out. It came out a little bit earlier than we expected, but that time difference was within the family of variation that we expect from the atmosphere. So that is not really a surprise to us. You know, Tim's talking about analyzing all the data. One of the great things about landing here is we have all of this photo documentation from 4 different camera systems that were around. We also have the WB imagery. We don't have that available yet. We have not been able to look at that. I can tell you that I could not see whether or not the drogue was deployed in the imagery that I had available in real time in the ops room. That's not necessarily an indication that it did not deploy, but I can't confirm that I saw it in that imagery. But what we're going to do is what we always do is go back and look at this in great detail, and that's one of the advantages of landing here is we've got a ton of data, and we're going to go back and look at that, and we'll reconstruct exactly what happened. Yep. But the bottom line is we landed, when the main parachutes came out, that was the moment that I was waiting for, and that for me was success. I knew that we had done, we were successful, and we were going to get that sample today.
And the simple fact of the matter is the drogue parachute deploys the main parachute. So just by the way that is designed, the drogue did deploy enough.
The drogue's on top of the main parachute, so it all had to come out.
That's where I say the robustness of this design, you know, kind of, you know, rolled itself up into a ball and said, I'm going to get this done, and it got it done.
We are now going to go to 2 questions on the phone, and then I will come back to the room. Our first question on the phone is from Jeff Faust with Space News.
Good afternoon. Question for Mike Moreau. You mentioned that the landing site was a little bit east of the center. How far off from the center was the landing, and was that entirely due to atmospheric variations or anything that might have happened with the parachute timing that caused that thing?
I'll talk a little bit about this because it's really part of the amazing work that the team did. Our ellipse, our final ellipse that we were looking at today was something on the order of 12 by 30 kilometers. That's not exactly, but that's approximate. So that's a lot smaller than the planning ellipse we'd have, because as we got closer and closer, things have shrunk down. Where we landed was probably 8 kilometers or so to the east. I don't have the exact number, but it was on the eastern side of that ellipse. But our team had been telling us for the last week or so they expected us to land to the east side of the ellipse, and that was based on looking at the actual forecasted atmospheric density and wind speeds, and things would take us to the east. So I was really excited. I sent them a little screenshot of where I thought the landing was as soon as it was there, because I was like, wow, you guys were great. You told me exactly where it was going to land, and that's where it ended up. So
I think you may have won the pool, by the way.
All right, thank you very much. The next question from the phone line is from Bill Harwood with CBS News.
Hey, thank you very much, and congratulations, everyone. 2 quick questions. One for Tim, just making sure I understand what you were just telling us. Are you saying the drogue definitely deployed, but you don't know if it inflated, or you just didn't see it visually? And for Dante, I'm just wondering what went through your mind the moment you heard that the main chute had deployed, or maybe you saw that with your own eyes. I mean, that must have been an amazing moment for you after all the years you put into this. Thanks.
You go first.
All right, yeah. We were in the helicopter waiting, and so all we got was telemetry from our range control officer here at UTTR. So I didn't have all the cool video and things like that everybody else was seeing here, so I was really trying to hear through helicopter noise. And we heard passing through 100,000 feet, passing through 60,000 feet, and I was getting a little worried, for sure. I knew things were supposed to be happening on a nominal timeline, that I wasn't getting call-outs, but again, we could have just had radio dropouts there. And then we heard main chute detected, and I literally broke into tears. I mean, and I'm probably going to do it right now just thinking about it, because that was the moment I knew we made it home. And, you know, I'm weary at this point. I've been thinking about this and focusing on it, and all of my energy and all of my will has gone into making this thing a success. And I knew the moment the chute opened, that was it. We knew what to do from that point forward. There was no surprises left. And it was overwhelming relief, gratitude, pride, awe, and really trying to convince myself that I wasn't dreaming, that it was actually happening, that the chute was open, that the capsule was coming down, that we got that science treasure in hand. And it's the end of a journey and the beginning of a new one, because we're going into the atomic realm. We're going into the mineralogy, the chemistry, the organics, and the history of the solar system, which is what I signed up for all those years ago, was to do the laboratory investigation on this material. So I'm getting really excited about getting into the lab and really digging into these samples and answering all the questions that have come up before we launch, and especially from our encounter with Asteroid Bennu. A lot of surprises there, a lot of new science ideas came out of that, and that's driving our sample analysis plan right now.
And Mike, about the drogue.
Yeah, and relative to the parachute deploy, the clarity of the videos that we do have and have had a chance to look at, especially the high-speed one, coincidentally is very clear at about the time that parachute deployed, and we can see the drogue chute deploy it. So we know the drogue chute was out and it deployed the main chute at that point in time. What we need to do is continue to comb through the information, the data, the video that we do have, just to see if we can understand how much time ahead of that point we can confirm or not whether or not that drogue was out.
Thank you so much. We have two people who've had their hands up for a while, this gentleman here, and then we'll go to the gentleman right behind him, and please identify yourselves. Yes.
Thank you and congratulations. Chris Kokinos with Astronomy Magazine. I have a two-part question for you, Dante, one scientific and one personal. Is there anything that you can tell from how the sample return canister was behaving, I guess you would say, as you were moving it, or the nitrogen flow that might tell you anything about the status of the sample inside? I know you had mentioned before it might be just highly pulverized. Is there any sense of that at this point, or you just have to wait until you open it? And then you said you were weary. When and where do you get a chance to just, like, I don't know, take a hike in the desert, go in the Tucson Mountain? When do you get a chance to just, like, take a breath and reflect and kind of rejuvenate a little bit? Thank you.
So we don't have any information about the nature of the return sample at this point. This capsule weighs 50 kilograms. We think we have 250 grams of sample inside there, so you really wouldn't be able to tell anything. And they wouldn't let me shake it like a kid in Christmas trying to see what I can hear inside there yet. So, and they probably won't let me do that, right, Eileen? So I have to be patient, and I'm really exercising patience. I understand we need to go methodically, systematically through the hardware. We have a very well-defined procedure. The curation team knows the importance of getting sample out to the science as quickly as possible while maintaining the integrity of the collection, and I'm fully on board with that. OSIRIS-REx is about the science, but it's also about the legacy, and the legacy is that long-term collection, and we work hand in hand together as science and curation to make sure both of those are achieved in a timely manner. In terms of when I get to relax, that's a good question. We've got a busy week ahead of us. We're flying to Houston tomorrow morning at the crack of dawn, so not tomorrow. And then Tuesday morning, we hope we get that canister open. And I expect we'll see some dust, and we have a plan to sample that dust and get into the science instruments at JSC right away, just to say, did we bring back what we thought, or is it something completely different? And knowing Bennu, it might be a little both, right? So I can't wait to see that. I have a big party planned on October 14th in downtown Tucson. The whole city is celebrating with us. Mayor Romero of Tucson declared today OSIRIS-REx Day, by the way. Thank you, Mayor Romero, for that. And so I think October 14th, we should have a pretty good idea of what the nature of the collection is. We should be at the final stages of allocating the first major masses to the science team. And yeah, we're going to throw down.
Fantastic. This gentleman, no, a little bit closer here, this gentleman right here. Thank you. Please identify yourself.
Thank you. David Brown, The New Yorker. Dante, congratulations to you and the team for an extraordinary achievement today. Dr. Glaze, I have a question about how a government shutdown might affect OSIRIS-APEX and whether any of the sample that was collected today might get out to laboratories before things go wrong.
Yeah, no, these are great questions. It's certainly something that's on the top of many people's minds at this point as we near the end of the fiscal year. So I'll address the first question first about APEX. As in the past, when there is a government shutdown, we've been through this many times before, all of our operating missions get accepted. We know that they are incredibly valuable assets, and so we generally get an exception for that to protect property. Which they are, and so APEX will continue operations as normal. As far as the samples, we are committed to this process that Dante mentioned, and ensuring that those samples are kept secure and safe for posterity. And so we will assure that they're safe. There may be some delay, a little bit of delay in the science analysis. As soon as they're safe, we will, make sure that we step back and do as we're told to do. But we will assure that they're safe.
Fantastic. We're going to take one more from the floor, and I'm sorry there are so many people, but I believe right there in the back had their hand up for a while, and then we will switch back to the phone lines before coming.
Good afternoon. Thank you all for joining us. My name is Spencer. I'm with Fox 13 here in Utah. Welcome to Utah. Glad you liked it here, and glad Osiris liked it here as well. My question is for anyone who wants to answer it, and I believe someone mentioned the OSIRIS-APEX mission, kind of handing it to the next generation. How important is it for things like this to inspire even the generation after that to get involved in STEM and get involved in wanting to explore outer space?
I'll start. That's okay. Yeah. So I think OSIRIS-REx is an excellent example of the inspirational value of these kinds of activities. The reason why we should be investing our taxpayer dollars in these missions of exploration. Of course, the science is fantastic. The engineering is beyond amazing. But the inspirational value is really where the long-term payoff comes from these. I started out as a young, naive assistant professor in 2004 when my mentor, Mike Drake, believed in me, brought me in as his deputy, and together we worked for 7 years to come up with a mission concept that was credible and that the agency felt like they could invest in with the right amount of scientific return. And I know Mike would be incredibly proud of that. And it was a key part of his vision from day one that this is about the future generations. And Danny Della-Justina, who's now the PI of OSIRIS-APEX, I officially congratulated her right when the SRC released from the spacecraft. My PI ship follows the capsule, and she takes the spacecraft on to the next adventure. She started with us in 2004 as well as a freshman at the University of Arizona when she enrolled in my Asteroids seminar. And she led a student experiment design for a discovery version of what we called OSIRIS back then. She was going to be the student experiment lead. She left for a little while to go pursue her advanced degrees, but came back as the imaging scientist, and now is the deputy PI for OSIRIS-REx. She'll continue in that role through the sample analysis phase and also as the principal investigator for OSIRIS-APEX. And she is strongly committed to bringing the future generations along with her on that team. And we've got 5.5 years to Apophis and then 18 months at that amazing target. And you're going to see a lot of young people involved in that mission. And I can just tell you, I love working with kids. I go out into the community quite a lot, Boys and Girls Clubs of Tucson, local Tucson schools. We're hosting a great event at the Tucson Children's Museum right now to have the city celebrate this activity. And I also teach undergraduate and graduate students. And so many of them said, we are here because of OSIRIS-REx. We came to Tucson because the OSIRIS-REx mission was based here, and it was just an amazing example of what people can do when we put aside our differences, we focus on a common goal. We can achieve great things. This country can achieve great things, but we have to work together to make that happen.
I'd like to add to that if I could. So I think that's a wonderful question, and a big part of why we do these missions is inspiring the next generation, and I'm a perfect example of that. I grew up on a dairy farm in Vermont. I was inspired by the Voyager missions, by some of the early space shuttle missions. You know, it was that got me interested in math and science. And then it was NASA research that helped to fund my graduate studies and brought me to working from a farm in Vermont to doing a job at the Goddard Space Flight Center, where I met an amazing mentor, Jerry Soffin. So that is just one of the biggest reasons why we do these missions. We're talking all about the science, but in order for our nation to be competitive in the future, we need young people to want to study math and science and technical fields. And this is just one aspect of that, but it's an amazing, rewarding aspect to work on some of these great challenges and the kind of teamwork that Dante talked about. So thank you for that question.
Thank you so much. Going back to the phone lines, we are going to take a question from Marcia Dunn with the Associated Press. Not hearing you yet, Marcia. Great. Well, I am going to go on to the next person, though I think Marcia might be on there twice, so we might need to go to her other phone line and see if that one works. For now, though, we are going to go to Robin Andrews with Popular Mechanics.
Hi, yeah, I'm kind of fascinated by the fact that the first to approach the capsule was an explosive ordnance expert to check for any unexploded munitions. So does that mean there was a very small but non-zero chance that the capsule, after its odyssey, could have softly touched down on an unexploded munition and been blown to bits, or was that just the extra safe?
Well, I'll take that because I've been the primary person working with our colleagues at the Air Force here who've just been amazing hosts. And I'll just say that the Utah Test and Training Range is an amazing place to land a sample. It's very flat, it's free of hazards, and they have these amazing tracking resources here. But it is a test range, and so they do all kinds of stuff here. And safety is our #1 priority. So this is a big place. The first thing that the Air Force does when they send their personnel out in the range is make sure there's no unexploded ordnance. We had unexploded ordnance check on our capsule when it arrived in the clean room. That was the first thing we did. So this is just kind of a standard procedure, safety first, and that's what we did out there today.
Great. I will try Marcia Dunn one more time now that we've seemed to have pulled a second line from her. So Marcia Dunn with the Associated Press. Let's see if this one works.
Hi, can you hear me? Can you hear?
Yes.
I'm going to ask my question. Hello, I'm wondering if the capsule was dented, dinged, bent at all, it touched down, and any idea what the final touchdown speed was? And Dante, how overwhelming was it when you finally got your eyes on the capsule and got up close to it? Thanks.
Sure. Well, being one of the first people that got to get out there and see the capsule, it looked great. I mean, it was charred, but it came in at 27,000 miles an hour, so we expected that. Otherwise, it looked perfect. There was no sign of any damage or distortion to the heat shield or the back shell that we could see. There was a little bit of char left in the tiny little crater that it made, literally like about this big across. So it was pretty much, we stuck the landing, and that's what OSIRIS has done consistently, so I wasn't too surprised. But it was like seeing an old friend that you hadn't seen for a long time, and it was great to see it. It was just great to see it. I did want to give it a hug. But, you know, I knew I'd be all sooty, and we were trying to collect environmental samples, so that really wouldn't have gone over well. But, yeah, it was amazing. I was there when it was encapsulated in the fairing. I was there when it was assembled and when it was installed on the spacecraft. I was there when it was nothing but a PowerPoint on a slide in a proposal that we were submitting to NASA with this dream that we were going to bring back samples from Bennu. So it was amazing and emotional. I've been emotional all day, and that was one of the key moments for me, was seeing that I knew we had done it, that we had pulled it off, as incredible as it seemed all those years ago, it came to be.
Great, thank you. Coming back to the room here, please, right in the front. Thank you.
Jonathan Amos, BBC News. Can I just go back to Eileen? When you took the heat shield off and the back shell, was there any evidence that you might have had some spillage of sample being on those surfaces when the taxam was put away? It was leaking, right? So I'm just wondering if there are little specks, little particles on those surfaces that need to be picked up.
That's part of the procedure, is to methodically go through and investigate that. Our purpose here in support of the science and engineering teams is specifically to document and recover anything that could be loose. I have not seen the airshell portion taken off, but when I was over there in the clean room, back shell was removed, and there wasn't anything optically visible from the exterior of the clean room. My team is working in the clean room in concert with the Lockheed Martin engineers and the science team, ensuring that we document and recover anything that could have spilled out. But at the time I saw it, there was no evidence of that. They're still working in the clean room this afternoon, so there is still a possibility that there could be some of those samples. They will be documented and recovered and put into containers to be brought to the Johnson Space Center, just like the science canister, to make them available to the scientific community. That's part of the process. We're not yet through that process.
Great, thank you so much. Again, one more from the floor. Also in the front row, here, this woman on the aisle. The microphone is coming around as quick as it can. Oh, in the front row on the aisle. Thank you.
Howdy, Allison McGraw, Texas A&M University. Sounds like the range of grain sizes may not be known in the canister yet, but could somebody speculate on how this could enhance thermal inertia or modeling of asteroid surfaces?
Sure, I'll take that. That's one of the key scientific objectives for our sample analysis program, is to characterize the thermal properties. When we were at the asteroid, and when we were even before that through our telescopic astronomical campaign, we had tracking data on this asteroid back to 1999, all the way through departure in 2021, so a fantastic baseline. And we did see thermal effects, the Yarkovsky effect, which I know you're an expert in, causing a decrease in the orbital velocity and therefore the semi-major axis of the asteroid. So absolutely, we have Dr. Andy Ryan at the University of Arizona, who leads the Physical and Thermal Analysis Working Group. We have partners in Japan, partners in Canada, as well as some special laboratory equipment that we've designed right at the University of Arizona to measure thermal conductivity, thermal skin depth, and bulk density, and other key parameters that will feed into understanding the thermal inertia, allowing us to do an even better job of constraining the energy balance in the regolith of the asteroid, which is one of the top science objectives. It's called out in our level 1 requirement to do that, actually. So yeah, it's a big part of our program, and feeds into the planetary defense initiatives, because these kinds of parameters really influence future trajectories of these objects. So if you want to have an accurate prediction of where they're going to be in the future, you can't just rely on Newton's laws, or even Einstein. You still have to go to the thermal properties and Yarkovsky to really get a complete solution.
Great, thank you so much. We are going back to the phone lines. Our next call is from Nell Greenfield Boyce with National Public Radio.
Hey, thanks for taking my question. This is for Dante. So the first thing you guys might be able to look at is dust, on the outside of the canister, or the sample container, the collection device that's inside the canister. What tests will be done on the dust, and what will you be able to tell from it? Like, what will be the first things you learn that we should know in the next few days?
Yeah, we have a great suite of analyses planned. We call this our Tiger team for a quick look analysis of the sample. There's some great instruments right there at Johnson Space Center. We'll be doing, and I'll get a little technical here, but Fourier transform infrared spectroscopy, which will give us a pretty quick assessment of the range of minerals that we see in there. We have scanning electron microscopy and energy dispersive spectroscopy. Scanning electron microscopy with energy dispersive spectroscopy to give us elemental abundances. We'll be sending some of the material to our partners at the Natural History Museum in London, who are experts in X-ray diffraction and characterizing bulk mineralogy using that material. So what we're really looking for is what hypothesis one, and if you're interested, I posted the sample analysis plan on archive.org, so anybody can download it. It's free to all. It's about 300 pages, so just get ready. If you're really wanting to dig into that, it's quite an engrossing read, I think. And it'll lay out hypothesis one, which is, did we accurately characterize the bulk mineralogy and chemistry of the surface of the asteroid? I.e., did our remote sensing instruments work, and did our data processing lead us to the right conclusions? So I'm going to be looking for the basics. Are there clay minerals there? Are there carbonate minerals? Are there organic molecules? Do we see the iron oxides, the other things that we predicted on the asteroid surface? I'm sure there's going to be surprises in there. Once you get into the dust scale, you'll probably start to see a wide level of diversity, but it's kind of like a sneak peek of what might be in store for us. We don't know if the dust, what we call the fines, there's intermediates, coarses, and large stones. There might be variations in mineralogy and composition by particle size. The larger ones may be more robust to disaggregation, and the loose stuff, like the one we crushed when we tagged the surface, may be preferentially in the fine-grained components. So it really is to give us a sense of what are we dealing with. Are we way out of the box in terms of what we built this big plan around, or does it look like, yeah, we got it pretty close, there's some surprises, but we can still continue with the sample analysis plan that we laid out?
All right, our next question is also from the phone line. Stephen Clark with Ars Technica.
Hi, thank you for taking my question. Most of my questions have been asked and answered, but I want to follow up with Dante. If you could, one of your answers a little earlier, take me back inside that helicopter with you this morning. I think if I understood your response earlier, some of the calls over the radio that you were receiving about the rate of descent weren't exactly what you were expecting. The drogue chute may or may not have been deployed on time. Just on the video, when I didn't see any sign of the drogue, I certainly had my heart pumping. I was going to see if you could talk a little bit more about your feelings inside the helicopter, as some of the calls maybe weren't exactly when you were expecting them.
Yeah, I'll take you back even earlier in the morning, Stephen, because it started out, there was several key milestones today that I was really paying attention to, things that we talked about a decade ago and longer, and it's like, okay, now today it's real. The first one was the go, no-go poll, right? We had to get approval. We had to get the flight dynamics team, the entry, descent, landing team, the spacecraft team had to say they're all ready. The range had to be ready. And, of course, our project manager had to have the final authority on that. We knew we were in good shape there, but you never know, right? It's like something could have happened in the wee hours of the morning when I was barely sleeping that changed that poll. So to hear everybody unanimously go, that was the first relief. And then it was powering up the batteries inside the SRC, because they had not been, there had been no telemetry from them for over 7 years since we launched, because they were passivated. They had a layer on top that prevented current from flowing. We had to burn that layer off. So I got the news, 11.44 volts, both batteries, because it's prime and redundant, both were online. And then I knew the parachutes at least had power, because if the batteries were dead, we knew we were coming in hard already early in the morning. And then, of course, release of the capsule from the spacecraft. We had Doppler tracking data. There was spacecraft indication that the commands had all gone according to plan. So that it was on its own. And then the divert maneuver, so that the spacecraft wasn't following the capsule in. So everything on the spacecraft kind of set me up into a reasonably good mood. And then I knew it was all about the parachute. That's the only thing that I needed to know, was that parachute deployed. So obviously I was keyed into that more than anything. It was hard to hear in the helicopter. I didn't have the cool video. I couldn't see what was on screen. And maybe that was a good thing, because I heard it was a little bit of a pulse-pounding moment. And I do ask myself, how many of those can you have in one lifetime, right? And I might be reaching my limit, I'm not sure, but it kind of feels like it today. And so it was, I knew we were looking at around 100,000 feet. We should get confirmation of drogue. And, we had our amazing range safety officer, Jasmine. I don't know if you're here, but she's been great to work with. And so she was the one that was actually getting the callbacks and relaying that back to us. And I was like, do we have drogue? And she's like, they're not calling drogue. And we're at 60,000 feet. And I think I looked at Scott Sanford and I was like, I don't know. I said, we should have drogue, but it could be coverage. It could be that we're not seeing it. I know the helicopter was having trouble because of the location where we had touched down and relays to get the video feed back here. And so I was mentally preparing myself, like, for the worst case scenario. I always said, this is like you're the championship game. You've just thrown the touchdown, winning pass, and you fumble it out of bounds. That's what my nightmare was. It's like, I can't lose this at the last minute. And so I was just trying to make sure I didn't totally break down in front of an international audience, right? And it's like, okay, you got to keep it together when you get out of this helicopter, deal with it, whatever is there, and then mourn if that's what you're going to have to do. But then within minutes, Jasmine said, main shoot. And I was like, that's when I just emotionally just let it go. Tears were streaming down my eyes. I was like, okay, that's the only thing I needed to hear. From this point on, we know what to do. We're safe. We're home. We did it. As I told Lori as we were getting ready, I can't believe I ate the whole thing, right? From soup to nuts, everything is on the flight program for OSIRIS-REx went smashingly, just smashingly well. And so enormous pride and gratitude and excitement on the next phase, sample analysis.
So much. We have time for one more from the room, especially if our panelists are quick in their answers. I will take this gentleman right here in the dark blue shirt. Passing it from the other side is coming to you. If you look the other way.
Thanks. Yes, I'm Justin Davenport from NSF. Bennu is a carbonaceous asteroid, and we now have samples from several asteroids. Which type of asteroid does the scientific community want in the future? Which type of asteroids are you looking at for the next sample return mission?
Well, I can tell you my personal preference, which is we're going, and it's a decadal survey priority. It's comet sample return, right? The next big small body sample return challenge is comet sample return, right? Because the one thing that we're not getting with carbonaceous asteroids are the volatiles, the things that make ices. And those are critical, especially with these icy surfaces getting irradiated. Lots of interesting organic molecules can form under those environments. So we've been working as a team, and these things, you got to stick with them to get a comet sample return mission credibly proposed to NASA at the next, we hope, New Frontiers opportunity. We think we'll be really competitive in that environment.
So I am sorry we don't have time for more questions. For those who didn't get their questions answered, please do write an email in, and we will try to get your questions answered. Stay tuned. You can follow the rest of the mission at nasa.gov/OSIRIS-REx, and we will have more information soon about leaving tomorrow on the C-17, which is parked just outside, to get those samples to Houston. We're going to end with some highlights.
Entry was at
EO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating.
EO milestone. We have confirmed parachute deployment.
Wow. And after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. The team on the WB-57 doing
EO
a great job.
milestone. We have touchdown. I repeat, EDL. SRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to Asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system. A sample carrying fixture.
Recovery operations. WB has located the parachute on the ground.
You just heard that confirmation from that high altitude plane locating that